Hello everyone, welcome to SISYA class. So today we are going to study about the basic concepts of motion. Means today we are going to learn about what is distance, what is displacement, what is velocity, what is the speed, and what is acceleration, and what is negative acceleration, or we know as retardation or deceleration. So let's get started. So first thing, we will study what is 1D motion. 1D motion, a motion which is happening in a straight line. For example, you have a ball. When you roll the ball on the ground, it moves or it rolls in a particular direction. Correct? So it moves in a straight line. So that motion, the motion which happens on a straight line, we say it 1D motion. For example, you are sitting inside a car and this car moving in a straight road. Right? So this is your 1D motion because you are moving in a straight road in a straight line. Got it? So that's a 1D motion. So we will study 1D motion first, then we will move on to 2D motion, and then we will see what kind of motions are there, basically 3D motion. Okay. Now let's differentiate between distance and displacement. For example, there is your home, like this. This is your home. Right? And somewhere here is your school. Right? And the road which is connecting from your home to your school has some turns, right? Obviously, road has turns. We know that, right? So you started from your home and reached to your school through the turns, through the turns. First left, then right, left, then right, right? Okay. So for this way, you have covered around, let's say, 500 meters. Means you have covered around half kilometer. So this will be your distance. If someone asks you, let's say your friend asks to you, how much you have traveled from your home to school? You will say 500 meters, right? But you have traveled on the road, right? You have traveled on that road. The road has some turns, first left, right, then finally you have reached to your home. Right? So this is if the person asks you how much you have traveled, then you will say 500 meters along the road, along the path that you have traveled. So the total distance you have covered along the path is called distance, or total length of the path is called distance. So in this case, your distance is 500 meters. Right? So here you are only telling the value. You are expressing the value, the length of the path. You are not saying I am coming from where to where, in which direction. You are not mentioning any direction. Just remember this point. You are not mentioning any direction here. You are just saying only that I have covered 500 meters. That's all. Now, so scalar quantity. So distance is a scalar quantity. Let me tell you what is a scalar. Scalar quantities are those quantities which are having only magnitude, means they only shows the value. For example, time, right? You will say the time taken to move from your home to school is, let's say, 30 minutes. You have covered 500 meters in 30 minutes, right? So the values, the physical quantities which only have magnitudes are called scalar quantities. Similarly, if I talk about displacement, right? Displacement is a very peculiar thing. So displacement is the shortest path between initial position to final position. For example, if I draw a shortest path from your home to your school, let's say this one. So the shortest path will be a straight line, na? This one. This is a straight line. This is the shortest connecting path. It doesn't matter there is road or not. It doesn't matter. Displacement has nothing to do with the road, right? It is the shortest connecting point. You can say these can be imaginary as well, right? It is the shortest distance between initial and final position. So this is the shortest distance, as well as it shows the direction, in which direction I am going. For example, if I say this particular direction is east direction, right? So here your displacement will be, let's say the shortest path has distance or has length of 100 meter. So your displacement here will be 100 meters towards east. correct? Now another example. Here is basically a runner running on a semicircular track, right? So if I want to calculate how much distance he has traveled from its initial position, this is its initial position and this is his final position. Let's draw it in a simple manner like this, right? Or you can draw it like this. This is your initial position and this is your final position. So this is a semicircular track. It must have some radius, right? Let's say this radius, since it's a semicircular path, so let's say this radius is capital R. So it is running from here initial position to final position. When it reaches to final position, how much distance it has covered means the total path length. So what is the periphery of semicircle? It's pi times R. So that will be its distance, the total path length. Okay. So the distance here will be pi times R, the periphery of a semicircle, correct? Now, if I ask you, what is the displacement? What is the displacement? Right? So displacement is the shortest path between initial and final position. So connect these initial and final position, right? This is the shortest path, this one, right? So how much it will be? How much is the length from initial to final position in shortest way? It's R times R, means 2R, correct? So this is 2R. Got it? So this is 2R, means the displacement you have basically covered here. So the displacement is 2R and there must be some unit, let's say meters, towards east. Clear? Okay. Now, similarly, let's talk about speed and velocity. What is speed and velocity? So the same concept that we talk about what is speed and velocity as we talk about the distance and displacement, right? So distance, again here is scalar quantity that shows only the magnitude, and the displacement means it shows the magnitude as well as the direction. So similarly, in this case, speed and velocity, speed is a scalar quantity that shows only magnitude, and velocity is a vector quantity that shows you the value as well as the direction. Okay, so the speed, since speed is a scalar quantity, so it relates with a scalar quantity distance, right? So speed is defined as, if I denote speed, let's say u, I am denoting the speed with symbol u. So here the formula will become as the distance divided by time, right? Now, if we want to measure velocity, then velocity will be measured through a vector quantity, na? You can't measure using the distance. You can only measure the velocity by using the displacement, because displacement is also vector. So hence the velocity is vector, right? So the velocity, if I define the velocity as v, so that will be the displacement divided by time, right? Clear? And velocity will have magnitude as well as direction. Now let's talk about acceleration. What is acceleration? Acceleration is nothing but, for example, let's take a quick example. So let's say there is a car. Initially, it is moving with velocity v1, and after some time, its velocity becomes v2. And the time it has taken to change its velocity from v1 to v2, let's say the time is t. The time taken is t here. So rate of change of velocity is called acceleration. Whenever there is a physical quantity associated with the rate of change, just divided with time. For example, here acceleration, rate of change of velocity means divide the change of velocity with respect to time. That will be your acceleration. So here I am denoting acceleration with a, that should be final velocity v2, initial velocity is v1, divided by the time taken between the change in velocity, means going from v1 to v2, that should be the time t here, correct? So that is our simple acceleration. Since acceleration is associated with velocity and velocity is a vector quantity, so hence acceleration is also a vector quantity. Got it? because time is a scalar, so scalar has nothing to do with it. But velocity is a vector quantity, that's why the acceleration is also a vector quantity. It has magnitude as well as direction. Got it? Clear? Now let's talk about retardation. So retardation means negative acceleration. For example, if your car let's say started with 30 km per hour, then after some time the velocity is increased to, let's say, 60 km per hour, means your velocity is increasing. Now if you calculate the acceleration in this case your acceleration will be positive. Why? Because you are speeding up, or your velocity is getting increased with respect to the time, right? Now examine a scenario where you are sitting in a car and your car is moving with, let's say, 60 km per hour, and finally red signal came, right? And you start applying the brake on your car. Then finally when you reach to the signal, your car stops. So your velocity is changing from 60 km to 0, right? Basically you are stopping the car, na? So your velocity is changing from 60 to 0. In this case, if you calculate the acceleration will be negative. In this case, the negative acceleration is called retardation. Negative acceleration is called retardation. Got it? Acceleration is you can say acceleration has two types: positive acceleration and negative acceleration. And negative acceleration has a separate name, that is retardation. Let's talk about uniform and non-uniform motion. So uniform motion means in equal times. For example, just let me give you a good example. For example, let's say this is a road which is having, let's say, 1 kilometer distance, right? And I have divided in basically, let's say, half and half. So this is 500 meter and this again here is 500 meter. Now this 500 meter is traveled by you in same time t, right? And in same time you have covered this 500 meter in same time t. Means you have covered equal distances in equal times. Got it? So in this case the motion is called uniform. Clear? Now if I talk about non-uniform motion means unequal distance in equal times. Unequal distances in equal times. For example, let's say if you are moving slow, then let's say the time cover to 200 meters, time covered to 200 meter is, let's say, t. You have covered 200 meter in particular time t, right? And when you increase your speed, you will cover the same, you will cover 800 meter, let's say, in same time t. Why? Because you have increased your velocity. Got it? You have increased your velocity. So here you have taken the same time t in order to move the distance of 200 meter as well as 800 meters. Got it? So here basically you are covering unequal distances in equal times. Got it? So that is called non-uniform motion. That is a type of non-uniform motion. Okay? If you like this video, follow SISYA class for more such content. Thank you so much.